Good morning, students, and welcome you back to this session. In this video, we shall continue our discussion on sets, indices, and logarithms. This is your facilitator, Sir Isaac, Akuse Methodist, Senior High Technical, Mathematics Department. We are still on sets under Additional Mathematics Year 1, Learner Materials. In our last video, we looked at the definition of sets, and we also looked at some types of sets and some rules of sets and how to simplify a set. In this video, we shall continue with our discussion and move to addition and subtraction of sets. Sets are added and subtracted in the same way as algebraic expressions. Just as we add or subtract algebraic expressions by grouping like terms, we do the same for sets. That is, we add and we subtract sets by grouping like terms. For example, if we have 2 root of 2 plus 5 root of 2, we can see that in this set, 2 and 5 are the rational numbers in the set. Therefore, we group 2 and 5 together as 2 plus 5. Then we factorize the 2 out, which becomes, so 2 plus 5. Then since this and this, they are the same, that is the set in 8, we factorize it out, then we have root of 5. So the final answer becomes 7 root of 5. And that is the sum of these two sets. The sum of these two sets. Sorry, there's a mistake here. The set is 2. Is 2. So it's supposed to be 2 here. So we have 7 root of 2. 7 root of 2. And that is the sum of the two sets. We can also pick another example. For example, 2 root of 2 minus 5 root of 2. So here, the rational numbers are 2 and 5, and they are the like terms. So we need to subtract 2 minus 5. Then we just pick one of the sets. Since they are equal, we factorize that out. So the answer becomes negative 3 root of 2. And that is how to add or subtract sets. Now let's look at an example. We have root of 24 plus root of 96 minus root of 600. So we have to start with the 24. We can write 24 as a binomial. So 24 can be written as 4 times 6, where the 4 is a perfect square. When we come to 96, we can also write 96 as 16 times 6, where the 16 is a perfect square. Then 600 can also be written as 100 times 6, where the 100 is a perfect square. Now we can split them into two compound sets. So we have root of 4 times root of 6. Here we have root of 16 times root of 6. And here we have root of 100 times root of 6. Now, since root of 4, root of 16, and root of 100 are perfect square, we will get 2. Root of 4 is 2. Then you multiply it by the root 6. So 2 root 6. Root of 16 is 4. Then you multiply by the root 6. And root of 100 is also 10. Then you multiply by the root 6. So finally, we have seen that there is root 6 here, root 6 here, root 6 here. So what do? We factorize the root 6 out. Then we are left with the rational numbers, which is 2 plus 4 minus 10. So we have 2 plus 4 minus 10 put in parentheses, then root of 6. And that gives us negative 4 root of 6. That is the solution to example 1. Now example 2. We have root of 147 plus root of 75 minus root of 9. Now let's take 147. You have to look for a perfect square multiplying another number to give us 147. So you can try with your calculator. So you can see that 49 times 3 will give us 147. So we can write 147 as 49 times 3. Then 75 can also be written as 25 times 3. 9 is a perfect square, so root of 9 will just give us a natural number, which is 3. Now, we can expand or simplify it into two different sets. So we have root of 49 times root of 3. Then we also have root of 25 times root of 3. Then our negative 3 is standing alone. Root of 49 is 7. 7 root of 3. Then root of 49 is 7. Then it multiplies the root of 3 to be 7 root of 3. Then root of 25 is 5. Then it multiplies this root of 3 to be 5 root of 3. Then we have our negative 3 here, which has to be here. Now, let us focus on this because that is the set part. So we can factorize the root 3 out. Then we are left with 7 plus 5. 7 plus 5 root of 3. Then we subtract the 3 from it. Now, since this is a set, we cannot subtract 3 from it direct. So we just leave the answer as 7 plus 5, which is 12 root 3 minus 3. And that is the final answer. Let's look at these examples. Simplify. Example 3. We have to simplify 4 root of 2 plus 5 root of 2 minus 7 root of 2. Now, since the sets are all the same, we just have to factorize the root of 2 out. Then we are left with the constant or the natural numbers. So we have 4 plus 5 minus 7. And that gives us 2 root of 2. And you can try hands on this. Follow the same steps to justify the answer here. To justify the answer here. Now, this is also example 5. Go through the solutions. Just follow the steps. Make sure that you have group lighted. Let's go through this together. So Root of 12 can be written as 4 times 3. 32 can be written as 16 times 2. 50 can be written as 25 times 2. Remember that the 25 here, the 9 here, and the 16, also the 4, are all perfect squares. So we can now write them as compound sets by splitting them into 2. Root of 4 times root of 3, root of 16 times root of 2, root of 9 times root of 3, then root of 25 times root of 2. Then we can see that this part will give us 2. So it will be 10 times 2, then times the root of 3. Then here, root of 16 will give us 4. So it will be 12 times 4, then times root of 2. Root of 9 will give us 3. So we have 7 times 3, then times the root of 3. Then root of 25 will also give us 5. So we have 13 times 5 times root of 2. Then we can continue to simplify. Now remember that in this set we have one set being root of 3, root of 3. Then we have another set of the form root of 2 and also root of 2. So we need to group like terms in that respect. Now watch here. 10 times 2 will give us 20. So we have 20 root of 3. Then we have 12 times 4. That will give us 48 root of 2. Then here we have 7 times 3. 7 3 is 21. So we have negative 21 root of 3. Then we have 13 times 5, which is 65 root of 2. So when you get to this point, we have root of 3 here. We have root of 3 here. We have to combine the two. So we have 20 root of 3 minus 21 root of 3 as a like term. Then we also have root of 2. So 48 root of 2. We also have 65 root of 2. So we can also put that together as 48 root of 2 plus 65 root of 2. So as another like terms, then 20 minus 21 will give us negative 1. There is no need to write a 1. So it is negative 1, then root of 3. Then here, 48 plus 65 will give us 113, then root of 2. Now, because here is root of 3 and here is root of 2, we cannot add the 2. It's just like adding oranges to mangoes. When you add 2 oranges to 2 mangoes, what will you get? You will not get 4 oranges and you will never get 4 mangoes. You will still get 2 oranges and 2 mangoes. Therefore, negative 3, negative root of 3 plus 113 root of 2, since they are all different sets, you will still get that same value. You cannot add. And that is the final answer. Now, let us quickly move on to multiplication of sets. We multiply sets in the same way as algebra algebra, including the distributive property. So we'll be using the distributive property, which states that A multiplying B plus C is equal to A, use the A to multiply B, and use the A to multiply C. So we have A times B plus A times C. Or if you have a multiplication of two binomials of the form A plus B times A, or let's say C plus D, then we can use the A to multiply C plus D. Then plus we also use the B to multiply C plus D. and this is distributive property. So A, you distribute A, that is multiplication is going to be distributive over addition. So A multiply C and also multiply D, then the same thing happens for this, and that becomes the expansion of this binomial using the distributive property. So this same concept that we built under algebra will be used here under sets. So for example, let's say you have root of 3 multiplying 2 plus root of 3. We apply the distributive property to solve this. So first of all, we use the root of 3 to multiply 2. Then we also use it to multiply root of 3. So we are going to get root of 3 times 2, and that gives us 2 times root of 3. That's 2 root of 3. Then plus, we have root of 3 times root of 3. And remember that if you multiply 2 equal sets, you are going to just square 1. We studied that in our last video. So that is going to be this. So the final answer is supposed to be 2 root of 3. Then the square will cancel the square root. So we have 3. And that is the answer to this multiplication. So we will look at this. Let's look at some examples. Simplify the following. So the first one is 5 root of 3 times 13 root of 3. So here we can see that we have root of 3 here. We have root of 3 here. So what happens? Now there are two sets. The root of 3 and the root of 3 are sets. The 5 and the 13 are rational numbers. So what we do is that we still have to group like terms by taking the like term, that's the 5 and the 13, multiply them. 5 times 13. That is the rational part of the set. Then the irrational part, which is root of 3 and root of 3, you also multiply. So you have root of 3 times root of 3. But we know that root of 3 times root of 3 can be written as root of 3 squared, which is the same as 3. So finally, we have 5 times 13 times 3. And the final answer will be 195 as it is indicated here. Let's try the next example. 10 root of 11 into bracket 3 root of 2 minus 2 root of 11. So to solve this one, we have to start by expanding. So we use this to multiply this, then we still use it to multiply this. So we are going to have 10 root of 11 times 3 root of 2. Then you bring your minus sign, then 10 root of 11 again times 2 root of 11. So here we have applied the distributive property. That is, multiplication is distributive over subtraction, and that is what we have applied here. Now when we get to this point, we have 10 root of 11 times 3 root of 2. So what we do is that we take the rational numbers, that is 10 and 11, 10 and 3 together, and multiply. So 10 times 3, we have it here. Then the rational part, that is the set part, which is root of 11 and root of 2, we also multiply to get root of 11 times root of 2, which is root of 11 times 2. So we are done with this part. Then we bring our minus sign here, come to this part. So when you come to this part, here the sets are the same. Root of 11, root of 11. So just factorize 1 out. Then once you factorize 1 out, so since it is root of 11, sorry, it is multiplying. So because it is multiplying, we just have to multiply root of 11 by root of 11. And that will give us root of 11 times 11. Then when we take the negative 10, the 10 and the 2, we also multiply. So we are going to have 10 times 3, which is 30. Then root of 11 times 2 gives us root of 22. Then you bring your minus sign there. Then here, 10 times 2 is also 20. 10 times 2 will be 20. Then root of 11 times root of 11 will just be 11. So in all, we are going to have 30 root of 22. Then this part is not clear. What they did was that when you get to this point, remember that we are going to take negative, that is 10 times 2. So 10 times 2 must give us 20. Must give us 20. Then root of 11 times root of 11 is going to be root of 11 squared. The square will cancel the root, so we have 11 like this. Then 20 times 11 will give us 220. 20 times 11 is going to give us 220. So that is what would be for this part, 220. Then finally we have 30 root of 22 minus 220. Now again, remember that this is a rational number. This part is irrational. It is a set. So we cannot subtract it. When we get to this point, we maintain it as it is. Let's look at question, the third one, I. We have 2 plus 3 root of 3. And we have 4 minus 5 root of 2. So again, this is a multiplication of two binomials. So what we need to do is to also expand using the distributive property. So start with the 2 and use these 2 to multiply the entire bracket here. Then plus, we also take the second part, which is 3 root of 3, and still use it to multiply the second bracket. Now we can expand using the distributive law. So 2 times 4 is 8, and 2 times negative 5 is negative 10. The root 2 is there, so you bring it. When we get to this point, 3 times 4 is 12. 12 root of 3. Then 3 times negative 5 is negative 15. Then the set part, which is the root of 3, must also multiply the set part, which is root of 2. So root of 3 times root of 2 becomes root of 3 times 2, and that will be root of 6. And that is what we have here. So it's going to be 15 root of 6. Now, when we get to this point, we need to simplify. But you realize that this is the only rational number here. This is a set, but this set is different from this, and it is also different from this. So they are all different sets. Therefore, there are no like terms to add or subtract. So we leave our answer here. This is root of 6. It's different from root of 3, and this is also root of 2. So we can't add them, and this 8 is also a natural number. So basically, this is the simplified form. We can't continue. We leave our answer here. Now, there are more examples to solve, but I'm going to leave some for you to also try hands on. Leave some for you to try hands on. So let's look at the vein. That is the fifth one. This one is 3 minus 4 root of 3 all squared. Now we know that any number squared is just the number times itself. So if we have 3 minus 4 root of 3 squared, it is the same as 3 minus 4 root of 3 times itself. Times itself. So we have this. Then we still apply the distributive property where we take the 3 to multiply the last bracket, which is 3 minus 4 root of 3. Then we also take the negative 4 root of 3 to multiply the second bracket again. Then we distribute through. So 3 times 3 give us 9. 3 times negative 4 will give us negative 12. Then it multiplies the root of 3. Minus, here we need to take note, there is a negative sign here. So this negative 4 root of 3 times 3, the 3 will multiply the 4 to be 12. So we have negative 12 root of 3. Then here, because there is a negative sign here and there is another negative sign here, negative 4 root of 3 times another negative 4 root of 3, the negative and the negative will cancel to be positive. Then 4 times 4 is 16. Then root of 3 and root of 3 is the same as root of 3 squared. The square will cancel the root, so we will get 3. Then from here, we can still simplify. So we have 9 negative 12 root of 3, and we also have negative 12 root of 3. So this part, or let's take it this way, we have 9. This is also a rational number. 16 times 3 is 48. So we can add it to the 9 to get 9 plus 48. Then we have negative 12 root of 3, negative 12 root of 3. So negative 12 will give us negative 24 root of 3. Then the 9 plus the 48 is 57. So the final answer is 57 minus 24 root of 3. So that is also for this question. So we can solve more of that. Let's look at the VI. The VI, we have 4 root of x multiplying 5 root of x minus 10 root of y. Here we can go ahead and multiply through. So we are going to multiply the 4 root of x by 5 root of x and also by 10 root of y. So we have 4 times 5. Here we solve this straightforward because we are assuming that at this point you are getting the concept. So this is how it goes. 4 times 5 will give us 20. Then root of x times root of x will give us root of x times root of x must give us x. Must give us x. There is a mistake here. It's supposed to be x. This part is supposed to be x, not root of x. So it's supposed to be x. Then we come here. 4 times negative 10 will give us negative 40. Then root of x times root of y becomes root of x times y, which is xy. So the final answer is supposed to be 20x minus 40 root of xy. That's the correct answer. Now let's come to VII. Here we have 4 plus 2 root of 3 all squared minus 4 minus 2 root of 3 all squared. Now, there are two ways of solving this problem. The first method is for you to expand the square. So you know that 4 plus 2 root of 3 squared can be written as 4 plus 2 root of 3 times itself. Then minus, this is also 4 minus 2 root of 3 times itself. You expand all the two binomials, you group like terms, then you get your answer. That is what they did here. So they use this to multiply itself, use this to multiply itself, expanded, they grouped like terms, and we got the final answer. Another alternative is to use what we call the difference of two squares. The difference of two squares. Now you have to know that if you have a squared minus b squared, this is difference of two squares. This can be factorized as a plus b multiplying a minus b. So we are going to apply this concept to solve this. Now take note that let this whole expression be a. So we have a squared here. And let this whole expression be b. So we have b squared here. So we are getting a squared minus b squared, which is just the same as this. And once we know this, its factorization or its expansion is going to be a plus b, then a minus b. So let's do that. Now we know that a plus b, our a is the 4 plus 2 root of 3, and our b is the 4 minus 2 root of 3. So we are going to have a plus b, which is going to be 4 plus 2 root of 3 plus the b, which is 4 minus 2 root of 3. That is for the first part. Then you bring another bracket. Then we have a plus b. Then we have a minus b, where the a minus b, the a is 4 plus 2 root of 3, 4 plus 2 root of 3, then minus, then the b is 4 minus 2 4 minus 2 root of 3, which is here. So basically, we have written this whole expression in terms of the expansion for multiplication of two binomials. Difference of two squares. Difference of two squares. So once you have gotten to this point, you can now simplify. You can now simplify. So what did they do? We can just simplify. Remember that here is 2 plus root of 3 and here is 2 minus root of 3. So they will cancel out. Then we are left with 4 plus 4. 4 plus 4. Then when we come to the second bracket, we need to expand. So we have 4. This negative 4, negative will expand. So we have negative 4 here. So we have 4 minus 4. Then the negative is positive 2 root 3. So we will get 2 root 3 plus 2 root 3 in that order. Here 4 plus 4 is 8. Then in this bracket, 4 minus 4 will cancel out. Then we have 2 and 2 will add to be 4. Then the 6 root of 3 and root of 3 will also add to be um, no, we factorize that. So once you factorize root of 3 out, you have 2 plus 2, which is 4 root of 3. And that is here. Then now we can multiply. Remember that this is a rational number. This is a rational number. So we can multiply the two. 8 times 4 is 32 root of 3. And that is also another way of solving it. So you can use the two methods and you will get the same answer. Now we are done with multiplication of sets. You can still look out for more examples and practice. Now we are moving on to the next thing, which is called conjugate of sets. Conjugate of sets. Conjugate sets are like mirror images in the world of sets. They are formed by simply changing the sign of the radical part in the set expression. For example, let's look at the conjugate. If we take the set root of 2 plus 3, its conjugate is simply root of 2 minus 3. That is when you change the addition to subtraction. So the conjugate of this is this. So it also means that the conjugate of this is also this, vice versa. So when I give you another one, let's see, a plus root of b. What is the conjugate of this set? The conjugate of this set is going to be a minus root of b. When I give you root of B minus root of C, what is the conjugate of this set? The conjugate of this set will be root of B plus root of C. So it is just writing the original set, but you are just changing the sign. If the sign is subtraction, it becomes addition. And if it is addition, it becomes subtraction. But one thing you need to also know is that to find the conjugate of just a single set, so for example, the conjugate of root of 2 is still root of 2. We don't do anything to it. The conjugate of root of 3 is root of 3. The conjugate of a is still a. And the conjugate of 2 root of 3 will be root of 3. Let's get this clear. The conjugate of 2 root of 3 is root of 3. We are only interested in the radical part. We are only interested in the set part. So the conjugate of 2 root of 3 is root of 3. Is root of 3. Let's get that clear. The conjugate of a root of b is going to be root of b. Let's get that very clear. So let's look at this table. Let's look at this table. So we have a set here, root of a. Its conjugate is going to be a, root of a. Example, if you have root of 2, the conjugate is root of 2. If you have a root of b, the conjugate is just the set part, which is root of b. Example, 2 root of 3, you have the conjugate to be root of 3. When you have a plus root of b, the conjugate will be just swap. Let the sign become negative. So a minus root of b. Example, 2 plus root of 3, the conjugate is 2 minus root of 3. Then a minus root of b, its conjugate is a plus root of b. So example is this. So we have a whole lot of examples here. Let's look at this. A plus b root of c, its conjugate, you have to change the sign. So it becomes a minus b root of c. Example is 2 plus 3 root of 5 is 2 minus 3 root of 5, and so on. So you can just look at this, and these are a summary of a set and its conjugate. Now, let's look at these examples. Try them. Pause the video and try your hands on these questions. Write down the conjugate set of the following. Write down the conjugate set of the following. Now, check your answers. You'll realize that the first one will still be root of 11. The second one will be 2 minus 3 root of 3. The third one is root of 3 minus 4 root of 2. And the fourth one is root of 6 plus root of 5. It must be noted that the product of a set that is irrational and its conjugate is a rational number or expression. That is, the expression is now rationalized as it is no longer containing a set. Now, what the note means is that if I give you, for example, root of 6 plus root of 5, root of 6 plus root of 5, then its conjugate will be root of 6 minus root of 5. So we are saying that if you multiply a set by its conjugate, the result will no longer be a set, or will no longer be an irrational number. Remember that all sets are irrational numbers, and one way of changing that irrational number to a rational number is by multiplying the irrational number, which is a surd, by its conjugate. So now we want to multiply this surd by its conjugate. Let's see what happens. Now we have learned that if you have a plus b multiplying a minus b, it is a difference of 2 squares, and its value is the same as a squared minus b squared. So we can apply that here. So since we are just multiplying root of 6 plus root of 5 by root of 6 minus root of 5, we can write it as root of 6 all squared minus root of 5 all squared. And know that the square will cancel the square root to be 6. Then the square cancels the square root to be 5. And 6 minus 5 gives us 1. Now we know that 1 is a natural number. It is also a rational number. So what has happened here? By multiplying a surd by its conjugate, we have rationalized the surd. We have rationalized the surd. So now the surd has become a rational number just by multiplying it by its conjugate. Another example is root of 11. This root of 11, we saw that the conjugate of root of 11 is still root of 11. Let's multiply the two. So root of 11 times root of 11 is the same as root of 11 squared, and the square will cancel the square root. So the final answer is 11, and we know that 11 is a rational number. That is a natural number. Good. Now let's look at how to rationalize sets. So I have just explained that to rationalize a set, multiply the set by its conjugate. Multiply the set by its conjugate. But let's see, we have a set. We have a set of the form 2 over root of 3. Now you can see that this set, the numerator is not is not an irrational number. 2 is a rational number, so the numerator is already rationalized. But when you come to the denominator, it is an irrational number, and we don't want the denominator to be in an irrational form. In mathematics, when we are writing numbers in their standard form, we ensure that the denominator, that is the divisor, is in a rational form. Therefore, what will we do to this irrational denominator in order to make it rational? So the process of transforming the irrational denominator for it to become a rational denominator is what we call rationalization. And we have learned that for you to transform an irrational number, that is a surd, to a rational number, you need to multiply it by its conjugate. So now the question is, what is the conjugate of this set, which is root of 3? We know that the conjugate of root of 3 is still root of 3. So you multiply it by root of 3. But remember that 2 over root of 3 is a ratio, that is a fraction. So whatever you do to the denominator, you have to do the same thing to the numerator so that the value of the ratio remains the same. So we also multiply the numerator by the same root of 3. So in that case, we are going to have 2 root of 3. Then all over, we have root of 3 times root of 3, which is root of 3 squared, and that will give us 3. Now, this fraction is the same as the original fraction here. The only difference is that we have changed the denominator, which was once irrational to rational. And the process is what we call rationalization. Rationalization. Now let's look at more examples. A over root of B. A divided by root of B. We can see that the denominator is an irrational number, that is a set. But we are saying that the denominator is not supposed to be an irrational number. Therefore, we have to convert it to rational number by the process of rationalization. So what do? Multiply the denominator by its conjugate, and the conjugate is root of b. And do the same thing up here, root of b. So it means we are multiplying a by root of b, and we have a root of b. Then all over, we have root of b times root of b, and root of b times root of b is root of b all squared. And the square will cancel the square root, so we have b. And that is the answer to this. Now let's take another example. 1 over 3 minus root of 5. Now this time, the denominator is still a set, which is irrational, but it is a binomial, two terms. So what is the conjugate of this binomial? We saw that whenever you have a binomial set, you have to multiply it by the conjugate, and the conjugate, you just have to change the sign. So we have 3 plus root of 5. But whatever you do to the denominator, you do the same thing to the numerator. So 3 plus root of 5. So our numerator will still be 3 plus root of 5. But our denominator becomes difference of two squares in the form a minus b times a plus b. So it's a difference of two squares. And this can be factorized as 3 squared, then minus root of 5 all squared. Let's get that clear. Let's get that clear. So we have 3 plus root of 5 all divided by 3 squared is 9. Then root of 5 squared is 5. So we are having 3 plus root of 5 all divided by 4. And that is the final answer. 3 plus root of 5 all divided by 4. Now there are some typo errors in the book. So the out there are just typo errors. Let's clear those things. There shouldn't be any error there. Okay, so we have 3 plus root of 5 all divided by 4, and that is the final answer. Now we can clearly see that the denominator has been rationalized, or it has become a rational number. Now let's look at these examples. Rationalize each of the following sets. So quickly, let me take you through this. To rationalize this, just multiply the denominator by root of 5 and also multiply the numerator by root of 5. So 1 times root of 5 is root of 5. Then root of 5 times root of 5, by now you should know that it is 5. So that is the answer. Let's do the same thing to this. Multiply here by root of 11 and also multiply the denominator by root of 11. We have 3 root of 11 all divided by root of 11 times root of 11 is 11. Good. Let's try this. You multiply here by root of 13 and also multiply here by root of 13. Now, root of 5 times root of 13 is the same as root of 5 times 13. We studied this. Then all divided by Root of 13 times root of 13 is 13. That will be root of 13 squared. You cancel out, then you have 13. So the final answer is going to be root of 65 all divided by 13. Now you try hands on this. Try this one. Try this one. Good. So the answers are there. You can check out the answers. Let's look at example 3. A carpenter was to cut 90 meters of a wood into 2 root of 3 meters. 2 root of 3 meters. How many pieces will she have? Now, if you have a piece of wood and you want to cut the wood into, let's say, 2 pieces, then it means that you are just going to have, if the wood, a carpenter wants to cut 90 meters of wood. So if the wood is 90 meters and you want to cut them into 2, you just divide 90 by 2. So you are going to get 45 meters each. If you want to divide it into 3, then you divide the 90 by 3 and you are going to have 30 meters each. But this time, the carpenter wants to cut the 90 meters of wood into 2 root of 3 meters. So the same thing happens. It means that out of the 90 meters, we are going to divide by 2 root of 3. So we still have a set here where the denominator is in an irrational form. So what do we do to rationalize? Multiply here by the conjugate. But remember that the conjugate of 2 root of 3 is only root of 3. Then you do the same thing to the numerator. So here we have 90 root of 3 for the numerator. Then the denominator, we have root of 3 times root of 3. That will give me 3. And it will multiply the 2. So we have 2 times 3. And that is going to give us 90 root of 3 all divided by 6. All divided by 6. And we know that 6 can goes into 90 15 times. Therefore, the final answer is 15 root of 3. And that is the answer. Now let's look at example 4. Let me take you through the first 2 examples. Then I'll leave the last 2 for you to also try your hands on. 1 plus root of 3 divided by 2 plus root of 3. So now, let the focus be on the denominator. What is the conjugate of this denominator? Is going to be 2 minus root of 3. So multiply the denominator by 2 minus root of 3 and do the same thing for the numerator. So you multiply both the numerator and the denominator by the conjugate of the denominator in this way. Then the next thing is to expand and simplify. So let us take it. Now for the numerator, remember you are going to use this. So 1, you take the 1 first to multiply 2 minus root of 3. Then you also take the plus root of 3 to multiply 2 minus root of 3. So here we have 2 minus root of 3. Then plus here, root of 3 times 2 will give us 2 root of 3. Then root of 3 times root of 3 is positive 3. That will be 3. Good. So from here, we are getting the same thing here. That is what we have for the numerator. 2 minus root of 3 plus 2 root of 3 minus root of 3. Now let's come to the denominator. With the denominator, it is a difference of 2 squares. That is 2 plus root of 3. 2 minus root of 3. So just take the negative part and square each term. So we have 2 squared minus root of 3 squared. Now let's simplify the numerator again. So from here, we see that this is negative root of 3. This is 2 root of 3. Here is 2 and this is negative 3. So 2 minus 3. 2 minus 3 will give us negative 1. Then here we have 1 here. We don't write it. So negative 1 root of 3 plus 2 root of 3. Negative 1 plus 2 will give us positive 1. So it will be 1 root of 3, which is the same as root of 3. So we are having negative 1 plus root of 3. And that is what we have here. Then for the denominator, 2 squared is 4. And root of 3 squared, the square cancels the square root. So we have 3. So in all, 4 minus 3 is 1. And any number divided by 1 is the same number. So we have negative 1 plus root of 3 as our final answer. Let's go to the B and try our hands on this. So this one, I want us to solve it together. Our denominator is 3 plus root of 3 plus 2 root of 3. So we want to rationalize it by multiplying it. Multiply this by 3 minus 2 root of 3. Then also do the same thing for the numerator. So also multiply this by 3 minus 2 root of 3. Now let us focus on the numerator and expand. So our numerator, we will take the 4 to multiply 3 minus 2 root of 3. Then plus, we will also take the root of 2 to multiply 3 minus 2 root of 3. Then also, when we come to the denominator, it is difference of 2 squares. This and this are the same. The only difference is the sign. So it makes it difference of 2 squares, which can be factorized as 3 squared minus 2 root of 3 all squared. Now let us expand the numerator. 4 times 3 is 12. Then 4 times 2 is 8. So minus 8 root of 3. Then when we come here, plus root of 2 times 3 will give us 3 root of 2. Then we have negative 2 times, so the 2 here will still be here. There is 1 here, so 2 times 1 is 2. Then root of 2 times root of 3 becomes root of 2 times 3, like this. Then the denominator, 3 squared is 9. Then the square affects the 2 and it also affects the root of 3. So 2 squared is 4. Then root of 3 squared, the square will cancel the square root. So we will have 3 here. Now, let us group like terms. We have 12. Then these 2 is root of 3. Okay, so we have negative 8 root of 3, then plus 2 root of 2. Then this part becomes negative 2 root of 6. 2 times 3 is 6, root of 6. Then divided by 9 minus 4 times 3. 4 3 is 12. So finally, we have 12 minus 8 root of 3. Then plus 2 root of 2. 2 root of 2. Then minus 2 roots of 6. All divided by negative 3. Negative 9 minus 12 is negative 3. So when you get to this point, you can leave your answer here because you cannot simplify it again. Remember that the sets there are not the same. The sets are not the same, and therefore we cannot simplify further. So we leave our answer here, and that is the solution. That's the solution to the question. So I'm going to leave with you the remaining questions. I'm going to leave with you the remaining questions. Remember, there are 4 questions. You will also try your hands on the C and the D. The C and the D. All right. Now let's move on to our last concept for the day, which has to do with finding the square root of a set. Finding the square root of a set. When 2 or more expressions involving sets are separated by an equal sign, they are said to be equal. Given 2 sets, a plus root of b and c plus root of b, if a plus root of b is equal to c plus root of d, then it follows that a must be equal to c and b must be equal to d. So let me come here clearly. Let's say we have a set a plus root of b, and we also have another set which is c plus root of d. Now, if we state that a plus root of b is equal to c plus root of d, this is called equality of a set. Then it must follow, if this is equal to this, then it follows that the rational part has to be the same. That is, a and c has to be the same. So a should be equal to c. Then the irrational part, that is the set part, has to also be the same. And that is going to be b should be equal to d. These are the 2 conditions that we are going to build on. So let's look at an example. Let's see, I state that 2 root of 3 is the same as, or 2 root of 3 is equal to a plus 1 root of b. And you are asked to find a and b. How do you solve it? So to find a and b, go back to the set. Since this set is equal to this, compare the rational part. So you could see that from this set, the rational part is 2. It means that it has to be equal to the rational part in the other set, which is going to be a plus 1. A plus 1. So we have formed one equation, and we can solve for a from here. So a should be equal to 2 minus 1, and our a is equal to 1. So we have our a to be 1. Now, if we also want to solve for b, compare the radicals, that is the numbers under the square roots. You can see that b must be equal to 3. So our b is equal to 3. And that is the solution to this set, this equation. And that is what we call equality of a set. Whenever 2 sets are the same, it means that the rational parts has to be the same and the radicals has to also be the same. So compare the 2 and find the missing value or the unknown. Now let's get back to finding the square root of a set. Now it will be better to pick your calculator and try to find square root of some sets. Find the square root of some sets. Now let's look at a set. Let's look at a set. Let's say you have this set, root of A plus root of B, and we square it. Let's try to do the expansion of this. Root of A plus root of B all squared is the same as root of A plus B. So root of A, we have root of A plus root of B multiplying itself, which is root of A plus root of B. So that is the meaning of the square. And this one, we can take root of A to multiply root of A plus root of B. Then plus root of B will also multiply root of A plus root of B. Let's expand this. When we expand this, we will get root of A times root of A is A. Then plus root of A times root of B is going to give us root of AB. Then here too, the same thing. Root of B times root of A will give us root of AB. Then root of B times root of B will give us B. Now from here, we can add the rational part, which is A plus B. Then also, we add the radicals or the sets, which is going to be 2 root of AB. 2 root of AB. So let's get this clear that this implies that if you have, this is a set, let's get this clear. We have seen that root of A plus B, root of A plus root of B all squared is giving us A plus B plus 2 root of AB. What does it mean? It means that if I should also square root both sides, this square will cancel the square root. Then I'm going to get the square root of A plus B, the square root of A plus B plus 2 root of AB is going to be equal to root of A plus root of B. Is going to be this. So what is happening? This A plus B plus 2 root of AB is what we call a set. It's a set. This is the rational part and this is the set part. So this whole set is of the form P plus Q root of R. This whole set can be written in this form, and it has been squared root. So we call this one square root of a set. And anytime you square root a set, you are going to get a result in the form root of A plus root of B. Let's get that clear. Let's get that clear. Now, if the set is not of this form, and it is rather of the form root of A minus root of B all squared, then it means that the whole expression will change to square root of A plus B minus 2 root of AB is also going to be equal to root of A minus root of B. Let's get these two clear. So these are identities. Square root of A plus B minus 2 root of AB is equal to root of A plus root of B. And square root of A plus B plus 2 root of AB is equal to root of A plus root of B. And that is what has been stated in the note here. That note that root of A plus root of B all squared is equal to A plus B, then plus 2 root of AB. And also root of A minus root of B all squared is equal to A plus B minus 2 root of AB. Let's get these two identities very clear, because it is going to help us to find the square root of a set. Now let's look at this example. Let's look at this example. Simplify. So there is a square root here. Let me make it clear for you to see. The square root is affecting everything. Simplify. So basically they are telling us to find the square root of the given set. Find the square root of the given set. So the first thing is that you should be able to state that this set is of the form, A plus root of B is of this form, So if you square root this set, you are supposed to get in the form root of A plus root of B. Let's take note of that. Remember that this is the radical part and this is the set part. This is the rational part and this is the set. So because the sign is addition, when you square root this set, the result is supposed to be of the form root of A plus root of B, just like we have here. The set is of this form, A plus B plus 2 root of AB. It is of this form. So if you square root both sides, you have to get the form root of A plus root of B. So we are going to apply the concept to solve this question. So we will start by saying that root of this set, which is 16 plus 2 root of 55, is supposed to be of the form root of A plus root of B. Is supposed to be of this form. Then we can square both sides. When we square both sides, the square will cancel the square root. Then we have 16 plus 2 root of 55. 2 root of 55. Now we need to also expand this. Remember that in expansion, you are supposed to multiply the set, which is root of A plus root of B, by itself, which is root of A plus root of B. And you can do that. I'm not going to go by this method. Let me just teach you a shortcut which I will be using as we move on. If you have, let's say, A plus B all squared, and I want to expand, instead of using the normal expansion method, the shortcut is that square each of the terms. So I'm going to have A squared, and I'll also have plus B squared. Then when you finish, multiply this A and B, and multiply it again by the 2 here. So it's going to be plus 2 times A times B. So you can rearrange it as A squared plus 2AB plus B squared. So that is the expansion. Let's take another example. Let's say I want to expand a minus b all squared. In this case, square each of the terms. So I'll square this one, a squared, then I'll also square b squared. Take note, whether it is positive or negative, the squares will always be positive. So a squared plus b squared. Then the next aspect is that use 2 to multiply a and negative b. So we are going to have 2 times a is 2a times negative b will be 2ab. That's negative 2ab. So we have negative 2ab. We can rewrite it as a squared minus 2ab then plus b squared. Now let's pick one more example. So let's say we want to simplify x minus 2 all squared. Instead of expanding, or I can just use the shortcut. So the shortcut says square each of them. So it's going to be x squared then plus 2 squared, which is 4. Then when you are done, use the 2 to multiply the x and the 2. Because the sign is negative, bring negative. So 2 times s is 2x times 2 is 4x. So we have 4x. You can now write it as s squared. Bring this part first. So negative 4x then plus 4. So this is one shortcut of expanding this kind of um, expressions. So we are going to apply that here. So instead of expanding it step by step, I can just pick one, that is root of a plus root of b, then I'll square it. So if I square it, the rule says that square each of them. So root of a squared is a, root of b squared is also b. Then these two will multiply the root of a and the root of b, and that gives me 2 root of a root of b, which is the same as 2 root of ab. So this becomes the expansion. This becomes the expansion. So I can write equal to a plus b, which is the rational part, then plus 2 root of ab, 2 root of AB. Now, when we get to this point, it has become an equation. It has become an equation. And remember that we said, whenever you have a said equation, we can compare the rationals and we can also compare the radicals. So let us compare the rationals and the radicals. So the rational numbers from this set, the rational part is 16, and here the rational part is a plus b. Therefore, for it to be the same, a plus b has to be equal to 16, and I'm going to call this one as equation 1. Then also we compare the radicals. What is under the root sign? We have 55 under the root here. We have AB under the root here. So we can see that AB is also equal to 55, equation 2. Now we need to solve these two equations simultaneously. So let's go to equation 1. From equation 1, we can see that A is equal to 16 minus B. That is from equation 1. Then we can substitute this into equation 2. So go to equation 2. In equation 2, wherever you see A, you put 16 minus B. So we are going to have 16 minus B, that is for A. Then multiplying the B, then that should give us 16. That should give us 16. We can expand. So we have 16 minus b squared should be equal to 16. And we can simplify. So to simplify, we have b squared should be equal to 16 minus 16, and b squared is equal to 0. So if b squared is equal to 0, it means that b is also 0. So we have gotten our b to be 0. Once b is 0, we can just go back to a, this part, and substitute it inside. So we can say that therefore our a is also going to be 16 minus b, which is 0. So 16 minus 0, and our a is 16. So we have gotten the values for a and what? B. Remember that we started by saying that the square root of 16 plus 2 root of 15 is going to be of the form root of a plus root of b. That is going to be the value of the square root. But we didn't know a and b. We have now solved for a and b, and we have seen that a and b is what? 16 and 0 respectively. So we can now go back to this and substitute the values there. So to substitute the value there, wherever I see a, I'll put 16 there. So I have root of 16, then plus root of b, which is 0. And the final answer is going to be root of 16 is 4. And this part is what? Nothing. So the answer is 4. The answer is 4. Now let us confirm whether this solution is correct. Let's confirm whether this solution is correct. So pick your calculator and find square root of 16 plus 2 root of 55. Square root of 16 plus 2 root of 65. So I'm going to take my square root. Oh, okay. So square root, let me clear everything. We have square root of, let me go back to the question to check. Square root of 16 plus 2 root of 55. Square root of 16, square root of 16. Oh, what's wrong with my calculator? Let me reduce my calculator. Okay, so let me clear everything. Square root of 16 plus root of square root of 16 plus root, another root of 25. Let me check. Or 55, root of 55. Is that a question? Okay, 2 root of 55. 2 root of 55. So there is supposed to be 2 here. Then there's a mistake. Let me correct it. Plus 2 root of 55. Okay, so let me close there. I think my calculator is not working very well. Okay, so let's go back to the question and analyze it well. Let me use my scientific calculator. I'm not getting the concept well. So I have square root of 16. So you can all try with me. Square root of 16 plus 2. Then square root of 55. Then I close the bracket. So the result is supposed to be 5.55 something. Let's go back to see. It looks as if there is an error somewhere. The answer is not supposed to be 4. So let me go back and analyze that. All right, so I have seen where the mistake is coming from. Now you can see that when we made A the subject in equation 1, we made A the subject in equation 1 to get A is equal to 16 minus B. That was from equation 1. So the next step is for us to substitute that value into equation 2. So the mistake was that we blindly substituted it into equation 1 again. That was a mistake. Since we made A the subject in equation 1, we have to substitute it into equation 2. So let's do that correction. Let's do that correction. So A is equal to 16 minus B. We are going to put it into equation 2. So from equation 2, wherever you see A, you write 16 minus B. 16 minus B, then it will multiply the B again. Then that should be equal to 55. That should be equal to 55. So from here we have 16 minus B squared, and that should be equal to 55. That should be equal to 55. Now let's make B squared the subject. So we have, or let's take all of them to the right hand side. We have B squared. Okay, so let's rather make B squared a subject. So B squared should be equal to 16. B squared should be equal to 16 minus 55. Okay, so there is a mistake here. Our expansion is supposed to be 16 times B. 16 times B is supposed to be 16B. So let's correct that one. There should be B here. Let me make that changes before we continue. So we have 16 times B is going to be 16B minus B times B will be B squared. Then that should be equal to 55. So from here, we can make or take all to the right hand side. So we are going to have B squared, then minus 16B, then plus 55. Plus 55, and that should be equal to 0. So when we get to this point, you need to solve. This is called a quadratic equation, and you should be able to solve this quadratic equation. So let's try to solve it by finding two factors of 55. Two factors of 55 such that when you multiply the two numbers, you are going to get 55, but when you add the two, you get negative 16. So let's look at those numbers. So we can see that this 55, when you take 55, we have two factors, that is 11 and 5. 11 and 5. But when we add 11 to 5, we will get 16. We are not going to get negative 16. So for us to get negative 16, we negate the 2. So the two factors will be negative 11 and negative 5. So we are going to rewrite the quadratic trinomial using this. So we have b squared. Instead of writing negative 16b, I write negative 11b, then minus 5b. So this is the same as negative 16b. Then plus our 55 equal to 0. So from here, we can factorize b out. When you factorize b out from the first two, you are going to get b minus 11. Then here too, I'll factorize negative 5 out. When you factorize negative 5 out, you still get b minus 11 equal to 0. So here, we can still factorize b minus 11 out. Then we will get b minus 5 equal to 0. So from here, b minus 11 has to be 0, and b would be equal to 11. Or b minus 5 has to also be 0, and b is equal to 5. So now we have two values for b. That is 11 and 55. That is 11 and 55. So we can substitute those two values into the a. Remember that we have a to be equal to 16 minus b. A is equal to 16 minus b. So we will say that if b is equal to 11, then what will be the value of a? Then a is going to be 16 minus the 11, and that will give us 5. So here a is also 5. And if b is rather 5, then our a will also be 16 minus the b, which is 5. Then our a will be what? Also be 16 minus 5 is 11. So we have finally gotten the answer. Remember that we are just looking for square root of a set. And we said the square root of this set is going to be of the form root of a plus root of b. So our answer is root of a plus root of b. But the problem is that there are two a's and there are two b's. So which one should we use? Good, we can use any of them. We can use any of them. So let's say a is 11. So we are going to get root of 11 plus root of b. Sorry, root of 11 plus root of 5. And that is the answer. Well, if you don't want to use a as 11 and you want to use a as 5, then you are going to get root of 5. But remember that if a is 5, your b is 11. So you also get root of 5 plus root of 11. But know that addition is commutative. Addition is commutative. So whether root of 11 plus root of 5 or root of 5 plus root of 11, they are the same. They are the same. So let us get that very clear. So in the nutshell, what we are saying is that if you take the square root of 16 plus 2 root of 55, the final answer will be this. This is going to be the answer. And if you want to be sure that your answer is correct, square this back and you have to get it. That is root of 11 plus root of 5 square. Square it. Root of 11 squared is 11. Root of 5 squared is 5. Then 2 times root of 11 times root of 5 will give us 2 root of 55. 11 plus 55 is what? 16. So 16 plus 2 root of 55. Let's go back to check. And you can see that that is exactly what we have there. 16 plus 2 root of 55. So that confirms our answer to be this. That confirms our answer to be this. Let's try one more example, then we can end the lesson. Calculate the square root of 18 minus 12 root of 2. Now this time it is negative. This time it is negative. Now because it is negative, know that the square root of this set, which is 18 minus 12 root of 2, is going to be of the form root of a minus root of b. This time it will not be plus because it is minus. Now the next step is to square both sides. Square here and square here. This square will cancel the square root. So we are going to have 18 minus 12 root of 2, and that should be equal to, let's square each of the terms. So root of a squared is a plus, sorry, okay, so it will still be plus. It will still be plus because negative root of b squared is still a positive number, which will be b. Then when you finish, you multiply 2 by root a and negative root b, and that will give us negative 2 root of a b. I just use the shortcut approach. However, you can multiply this expression by itself and take the expansion step by step. You will still get this. Now we have gotten an equality, that is a set equation, and we said that whenever you have a set equation, the rational part should be the same as the rational part. So a plus b must be equal to 18, and that gives us equation 1. Then we take the radical, that is the number. Well, let me check something. I think here is 12 root of 2, and here is 2. Good. So here we have 12 here, we have 2 here. They are not the same. So when we get to this point, we need to equate all of them because 12 root of 2 is not the same as 2 root of AB. So we cannot just equate AB to 2 because the 2 here is different from this. Now you recall that the first one we solved, they were the same. The first one we solved, here is 2, here is also 2. So the only thing we can compare is the 55 and the AB. But here, because here is 12 and here is 2, we cannot just factorize. We can't just factorize. Or if we want to factorize, then we need to apply a different breakdown before we will be able to factorize. So what we are going to do is that we are going to compare everything here to this. Therefore, we are going to say that 12 root of 2 should be equal to 2 root of AB, 2 root of AB, 2 root of AB. Then from here, what do? We need to break it down so we can still square both sides. When I square here and I square here, I will get 12 squared, which is 144. Then the root of 2 squared will be 2, so it will multiply it. Then that should be equal to 2 squared here is 4. Then root of AB squared, the square will cancel it, so you'll get 4AB. Then from here, I can divide through by 4 and divide through by 4. So 4 cancels 4. So I'm going to have AB to be equal to 2 goes into 4 2 times, and 2 will goes into 144. Let me check. 144 divided by 2, we have 72. So the whole result is going to be 72. Or you can check that up with your calculator. 144 times 2, then you divide everything by 4 and you will get 72. So when you simplify it, you are going to get AB to be equal to 72. And that is what we are going to take as our equation 2. That's what we will take as our equation 2. Now, from equation 1, we can make A the subject. From equation 1, we will make A the subject as 18 minus B. 18 minus B. Then we come and put it into equation 2. So it means that in equation 2, wherever we see A, we write 18 minus B. Then it will multiply the B again. Then that should be equal to 72. That should be equal to 72. Let us expand it here. So we have 18 then minus b squared. Sorry, we have 18b. 18 times b is 18b, then minus b squared, then should be equal to 72. Now let's group items. So we have b squared. I'm taking the negative b squared to the right hand side. I have positive b squared. 18b to the right hand side. I have negative 18b. Then plus 72 should be equal to 0. So this is also a quadratic trinomial. A quadratic trinomial equation. And we can solve it by taking two factors of 72 such that when you multiply, you get the 72, and when you add, you get negative 18. So those two numbers will be definitely 6 and 12. 6 plus 12 is positive 18, but here we have negative 18, so we negate this and negate this. Therefore, we are going to have b squared minus 6b, then minus 12b, then plus 72 equal to 0. Then we factorize the b out to get b minus 6. Then also we factorize the negative 12 out here, and we will still get b minus 6 equal to 0. When we get to this point, factorize the b minus 6 out, and we are going to get b minus 12 equal to 0. So what is happening? It means that our b minus 6 is equal to 0, and that is b is equal to 6, and also our b minus 12 is equal to 0, and our b is equal to 12. We have two values for b. We have two values for b. That is, b is equal to 6 and b is equal to 12. But you can see that from where am I? From this expression, we saw that a is equal to 18 minus b. A is equal to 18. Let me write it clearly. 18 minus b. A is equal to 18 minus b. So let's start. If b is equal to 6, then we are going to get a is equal to 18 minus 6. Then our a will be equal to 12. Also, if b is equal to 12, then it means that our a is going to be 18 minus the 12, and our a will be equal to 6. So it means that a can be 12 and b will be 6, or b will be 12 and a will be 6. But remember that we are looking for the square root of this, and we have stated that the square root of 18 minus 12 root of 2 is going to be of the form root of a minus root of b. So we know that the answer is going to be this. That's the square root of this is going to be this. But we didn't know a and b. Now we know a and b. But let's take note that the answers can be 2. Since we didn't specify, the answers can be 2. So what we will do is that we will introduce plus or minus, then we write a and b. So here we can choose any of the values. So we can say that let a be 12, So we are going to have root of 12, then minus root of 12. So sorry, we will not bring the square root. So the square root of this is going to be root of a minus b. So we are going to have the answer to be plus or minus root of, into bracket, root of 12, then minus root of 6. That's going to be the answer. Now remember that the answers can be two. If you write root of 12 minus root of 6, that is, if you take a to be 12 and b to be 6, but you can also take a to be 6. If you take a to be 6, then you are going to have root of 6 minus root of what? 12. Now, take note that these two values are not the same. They are not the same. But remember that 12 is greater than 6. So if the question should have stated that find the positive square root, find the positive square root, then it means that we are going to let A be greater than B. That should be a condition. A must be greater than B. Therefore, the only solution will be this one, because this value is a positive answer where A is greater than B, because root of 12 is greater than root of 6. But because the question didn't specify that we should find the positive square root, it means that when we get to this point, there are two answers to it. So you can have this answer or you can have this answer. So these are the two solutions to it. If you want to write it as just a single solution, then you only write one. So root of 12 minus root of 6. Then you bring your plus or minus here. When you bring plus or minus here, it is just like writing all the two, because it's just the same thing. When you take the positive aspect, then you get root of 12 minus 6. And when you take the negative aspect, negative times root of 12 becomes negative root of 12. And negative becomes positive root of 6. And negative root of 12 plus root of 6 is just the same as root of 6 minus root of 12. So you see that this one has also come in. So you can just write it as plus or minus root of 12 minus root of 6 as your final answer. Or if you like, you write all these two to indicate that A can be 12 and B can be 6, or A can be 6 and B can be 12. That is also correct. But in the case where the question says find the positive square root, in that case, the only solution will be this, because we want the final answer to be positive. And that will bring us to the end of this session. Try your hands on this. Example 3. You can see that in example 3, we are to find the positive square root. We are to find the positive square root. So you need to rewrite this one. You have to indicate that the square root of 11 minus 4 root of 6 is going to be of the form root of A minus root of B, where A is greater than B. This condition has to be established. So take your time and work on this. Thank you for watching, and see you in our next video. Bye bye.